Okay, I'm going to show you how I solve this pattern. This is from visualpatterns.org, right here, visualpatterns.org. And what a lovely site. They have hundreds of these visual patterns, and you discover algebra through this stuff. And I've been showing this with my students, and I didn't show this to them, but I solved it myself. And to me, it was kind of challenging. So this is pattern number 5, and the number of circles in step 43 is 3,787. So what I what you're supposed to do is you're supposed to figure out, okay, how is it growing? And try to create a rule for this. And that rule ends up being algebraic. And then you can do all kinds of cool stuff with that. I'll show you in just a moment. But the first step is, how is this growing? And at first, it looks like it's kind of, you look at the circles that you have, and then what? Here's this, and then this is here, and this is here maybe, and then I don't know. It's kind of not so obvious from here to here, but from here to here, it looks like this part's growing, and this part's getting larger. And I was thinking, okay, that you're adding circles each time, but maybe adding circles is the wrong way to think about this. And to consider the idea of negative space, like what's not being filled. And so what I then saw was this. I saw a tic-tac-toe board like this. And so there's a square, right? We're looking at a square here of a 3 by 3 minus this one and this one. So you have to take a couple things out. You have to remove a couple things. So this is a 3 by 3, right? And then if I did this, and then this, like that, yeah. What is this? A 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. This is a 5 by 5 with a few things missing, right? You're missing this and 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 this. Okay. Then the next one I think is a 7 by 7, isn't it? 1, 2, 3, 4, 5, 6, 7. Yes. And 1, 2, 3, 4, 5, 6, 7. Okay, so this is a 7 by 7, 7 by 7. So this is a growing thing. Now these are growing squares. So I know that this is going to be x squared. There's going to be an x squared somewhere in this rule. And then what I further saw is let's see, maybe I'll do it in green here. There is a square. Oh no, that's not green. I better do it in red. There is I saw a square right here, and that relates to this square here and this square here, right? And then finally, I'm thinking of another color. I could use black maybe. I saw this square here and this square here, and the other one doesn't even have a square. So when I look at this here, I'm thinking, okay, I think I know how I'm going to build this. So I'm going to move this down a little bit, and I'm going to share. And then I decided, hey, how about I try to make the next one? What would the next one look like? And so that is, I'll do that in blue. So this should be a 9 by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this one. 1, 2, 3, 4, 6, 7, 8, 9. And then further, that red square is right here. And the black square, oh, I can't do a black square right now. I'll make it a green square. The green square is right here that corresponds to the black squares in the previous ones. So, okay, what this means to me is you have to start, and I don't want to get into Desmos quite yet, but I'll show you that a little later. What this means to me is I have a square, and the overall square, so I have a square, and we put a little 2, so I have something squared. How do I get to that something? Well, this is item number 4, and this is item number 3. So item number 4 has 9 as a 9 by 9. So to get 9 from 4, you multiply 2 times 4 plus 1. So that'd be 2 times the item number plus 1. And so that entire thing, that is the square. That's the large square. And I'm going to erase a little bit here because I realize there's a lot going on here. So what this represents right here, this 2x plus 1 squared, it's something squared, which means this is a square. And this right here represents this entire thing. And take a look at it. It is 2 times x plus 1, and in this case x is 4. So it's 2 times 4 plus 1, which is 9 squared. That means it's a 9 by 9. That means there's 81 spots here available. But there's some that are removed here. There's a whole bunch that's removed here. And so what is removed here? What is removed? How many I mean, we have just 2 here. In each case, there's 2 there, there's 2 here, but I have to remove this whole square. So in 4, what is that? That's 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So this is item number 4, but it's a 5 by 5. So to get 5 from 4, you just add 1. So I'll say that red part is I have to subtract the x, which is 4, plus 1, and that's a square. See, so what that's going to do is that's going to remove all of this stuff here. This right here is responsible for that red square. But I have to add 2 to this here. So I better just add 2. Okay? Now I'm going to get down to this green square. And for the green square, let's see. What we have is this is a 1, 2, 3, 4 by 1, 2, 3, 4. Well, that's item number 4, and it's a 4 by 4. So that's just x squared. So I need to remove x squared, and I'll do that in green. So minus x squared. That makes this whole green box. But in each case, there's just a 1 right there. 1, 1, 1, and so on. So I got to add just 1. So I'll add 1 plus 1. And that is the polynomial that should create this. Now, to help us along, I am using Desmos. Ooh, look at that. It's a graphing calculator. And I'm going to move this in front in just a moment, but I want to show you what I did here. I graphed all the points. So let me bring this over here. Now, if I turn this into ordered pairs, this is item number 1, and it had how many circles? 1, 2, 3, 4, 5, 6, 7. So it had 7 circles. Item number 2, okay, item number 2 had how many? It had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Item 2 had 15, okay? So this is very important stuff. Super important stuff here. Number 3, I'll just tell you right now. Item number 3, there's a lot of stuff here, but item number 3 had 27 circles. Okay, so that's another important ordered pair that I'm going to use. And then item number 4, that had 43, I think. Okay, so all those ordered pairs are placed on this. And let me make sure that item number 4 had 43. Oh man, I have no idea. I think it did. Anyway, oh, I know how I can figure that out. So it looks like this is on top now, which is great. So item 4 had, oh, I get it. Item 4 had 43, and I'll close the parentheses. And so I turn these into ordered pairs. And these ordered pairs are important too because they really help me. They help me a lot, not only in the graph, and I'll turn back to the graph in just a moment. But let me look at those ordered pairs real quick. One was item 1 had 7 circles. Item 2 had 15 circles. Item 3 had 27. Item 4 had 43. Hopefully, let's see. What's the difference between here? This is plus 8. Is it? 7 plus 8 is 15. Oh boy. I hope. Let's see. From there to there, that's plus 12. Okay, good. And this is a difference of 4. So that means that this next couple here should have a difference of 4. So that means that increases by 16. And there you go. That tells me that this is quadratic because if the differences were the same here, that would be linear. But the fact that the differences are constant at the second level, that means it's quadratic, which means we're dealing with x squareds. Okay, so that confirms that this is an x squared type of thing. Okay, and further, it's going to be a parabola. So I use all these information. So I use the ordered pairs right here, and I kind of reorganized them here to see, well, what's the second difference in the y's? And it is, okay, cool. So I think I'm now ready to use my new equation, and I'm keeping an eye on this right here. So I'm going to have to zoom in a little bit so I can get all of it in there. Oh boy, there's a lot to, okay, so there's a lot to it. So I'm going to start typing it in, and hopefully, let's see, it's open parentheses 2x plus 1. I'm hoping that my line will go through all the dots, the order pairs that I graphed. 2x plus 1, close parentheses, square it. Okay. But I have to subtract x plus 1 squared. So x plus 1 squared. Oops. Oh wait, that did not work out. Okay. X plus 1 squared. Okay. But I have to add, now I have to add 2 to that. Okay. Wow. Looks like I nailed it right there. I don't know what else I have to do now. Let's see. Did I indeed nail it though? Nope. See, I'm still off a little bit right there. A little bit right there. So that's that last little part. Hopefully. Minus x squared plus 1. Ha! Exactly. Look at that. It goes right through all my dots perfectly. And then there should be one more. Yeah, right there. 4 and 43. Done. So that is that. Now, what do you do with this? I mean, so what? So I made that go through. Okay, that's cool. But what you could do is let me move this stuff aside. And oops. I want to group this stuff together here. So I want to, or maybe I don't have to group it together. So what do you do with this? This is the magic thing, right? So maybe what I could do is I could simplify this a little bit more. So this is some great practice now in simplifying. So um, 2x plus 1 squared means you have 2x plus 1 times 2x plus 1. So this has got a FOIL. So this is going to be 4x squared plus 2x plus another 2x plus 1. So that's 4x squared plus 4x plus 1. Yeah, okay. So that's good. Maybe I'll do this in red here to kind of keep myself organized. And then this is minus, that's x squared plus, if I FOIL that, that's x squared plus 2x plus 1 plus 2. So that's minus x squared plus 2x plus 3. Okay, I'll just rewrite that, minus x squared plus 2x plus 3. Hopefully I'm getting this all right, but I know how to check my work. And then minus x squared plus 1. So let's combine the like terms, which would be, let's see, I'm trying to use a different color, but I kind of, oh, blue. Oh, blue. I'll use blue for this. So 4x squared minus x squared minus x squared. So that's, so using this, this, and this, that's 2x squared. 4x plus 2x is 6x, and 1 plus 3 is 4, plus 1 is 5. So all that I think is really 2x squared plus 6x plus 5, but what I can do is I can check this and make it smaller, and I'm going to enter that into Desmos. So let's see, 2x squared plus 6x plus 5. Okay, well, that just shows that my algebra is wrong. How wrong is it? It's not good. It is not good at all. So something's up. So now, see, that's my check. Okay, I realize where I went wrong right here. Right here, it's minus all of this. So this changes the sign of everything. So what I need to do is I need to erase a little bit right in here and here. Yeah, that's it. And so that means that this changes, and this changes, and this changes. All that changes right there, which changes this and changes that. So what happens at this point is that's minus 2x minus 1. That's what that does. So that's minus 2x and then plus 1. And then that's minus 2x plus 1. And so we have 4x. Let's see, 4x minus 2x is 2x minus x squared. Oh, wait, no. Sorry. 4x minus 2x is 2x. So this should be still plus 2x on that part, and then 1 plus another 1. So 1 plus another 1 is 2. So let's see 2x plus 2. Let's see if that changes things. And what I'm really trying to do is I'm trying to give you an honest read on how I guess, figure out my mistakes. How do I fix my mistakes? And so here, no one is infallible. So we have 2x, was it plus 2? Shoot, I don't remember now. Yeah, it was 2x plus 2. Maybe it needs to be 2x plus... Wait, no. Maybe it needs to be 2x plus 4? No, 3. There we go. It's 2x plus 3. So where was my mistake on this? It was... Oh, yeah, it was this. It's 1, 2, 3. So that should have been a 3 right there. See, if you use different tools to cross-check yourself, like if I didn't have Desmos right here, I would not be knowing that I was making a mistake in my algebra right here. Okay, fine. So I have that. Now, the question now is if I have this 2x squared plus 2x plus 3, I like writing in yellow better. So if I have this rule, could I make one of could I make one of these? Ugh, so much stuff happening here. I'm trying to move it. Could I make one of these out of, I don't know, 80? Could I make one of these out of 80 um, circles? So what you do is, could this be equal to 80? Let's see. Well, then you got to do a quadratic formula, and you got to see if you can do that. Maybe 80 was a bad number. You know what? I'm going to cheat now because I don't really like doing 80 in the quadratic formula here. So, it wouldn't be that bad actually, I guess. But how about I do something that's a little more obvious, like 20? Okay. So I'm going to erase this and make it 20. So if I call this 20, is there a step where you have exactly 20 of these? So again, you still got to use maybe a quadratic formula or something. Subtract 20, and you have 2x squared plus 2x minus 17 equals 0. So now you use your opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of b is negative 2 plus or minus the square root of b squared, which is 2 squared, minus 4 times a, which is 2, times c, which is negative 17, all over 2 times a, and a is 2, so 2 times 2. Okay, so what we're looking at is negative 2 plus or minus the square root of 4 minus, I don't know, whatever 4 times 2 is 8 times 17. I don't know what 17 times 8 is. 7 times 8 is, oh my goodness, 56. And yeah, 5 plus 8 is 13, so that's 136. So 4 plus 136, the square root of that, negative 2 plus or minus over, 2a, which is 2 times 2, which is 4. So what we're looking at here is we have negative 2 plus or minus the square root of 140 over 4. And boy, I mean, this is negative 2 plus the square root of 40, which who knows? I mean, that's like 11.8. 11, it's about 11.8 over 4. There's no way that that's going to be equal to, well, yeah. Yeah. It's not going to work. It's not going to come out to a whole number. It's simply not going to work. Because what we're doing is we're solving for x. And if x is going to be some kind of funky decimal, the x is the number of steps. So how are you going to have, what is that? Negative 2, I don't know, it's negative, it's about negative 9, not negative, 9.8 divided by 4, um, which is, I can't even think off the top of my head, but it's going to be some kind of decimal. How are you going to have 2.8 steps? A figure 2.8. You're not going to have that. It's going to be whole number. It has to be a whole number. It'll tell you which step number that is that would have 20, and it's just not going to work. So that's what you could do with this kind of stuff. Anyway, I have fun with this. I have fun with the patterns. I have fun figuring all that kind of stuff out. It's just super fun, and I encourage you to visit visualpatterns.org and try some of those out. So that's about it. Thanks for watching.